In this video, we're going to find the value of a variable by simplifying an equation involving powers. So let's just copy this out. And we're going to use our laws of indices that we know to simplify this. Now, firstly, I can see that we have a power raised to a power here. So we've got a power here, the 7 to the power of k is a power, and it's raised to another power. So we're doing it to the power of 2. We saw when that happens, you can just multiply the indices together. So we do the k times the 2, which is 2k. So that's going to simplify to 7 to the power of 2k over 7 to the power of 7 is equal to 7 to the power of 3. Now, what can we do next? There's two things we could do. One is to just simplify the left-hand side, because I can see I'm doing a power divided by a power, and they have the same base. Remember, the base is the big number on the left. They both have a base of 7. And when that happens, when you're dividing two powers, you can subtract the indices. So these small numbers here, so the 2k and the 7, we could subtract that. So if we subtract those, I get 7 to the power of 2k minus 7, because I just subtracted those indices. And then that is still equal to 7 to the power of 3. Now, at this stage, can you see we've got 7 to the power of something equals 7 to the power of something? So those two somethings must be the same, right? So the 2k minus 7 must be equal to the 3. So we can therefore write 2k minus 7 is equal to 3. And now we've got a nice equation that we can solve. So we want to get the k on its own. How do we get the k on its own? Well, can you see the k has been multiplied by 2 and then we subtracted 7. So you want to undo the last thing that happened to k. The last thing that happened to k was subtract this 7. So we do the opposite to both sides of the equation. We add 7 to both sides of the equation. Remember, whatever you do to one side of the equation, you have to do the same to the other. Now, on the left-hand side, the plus 7 cancels out the minus 7, so it just disappears, leaving just 2k. And on the right-hand side, you can see we've got the 3 plus the 7, which is 10. And then finally, can you see, well, the k is being multiplied by 2. We want to get rid of the multiply by 2, so we undo it by doing the opposite. We divide both sides by 2. And if we do that, the divide by 2 here cancels out the times by 2. So we're just left with k. And then the 10 divided by 2 is 5. So that is the final answer. Alternatively, earlier, rather than dividing these two powers here, what we could have done is just multiply both sides of the equation by 7 to the power of 7. So I would have had 7 to the power of 2k is equal to 7 to the 3 times 7 to the 7. And now this time, I'm multiplying two powers together. If you multiply two powers together with the same base, you add the indices. So I do 3 plus 7, which is 10. So I'd have 7 to the power of 10. And that means, again, because you've got 7 to the power of something equals 7 to the power of something, that something must equal that something there. So we've got that 2k is equal to 10, and therefore k is equal to 5. And that was just a quicker way of getting to the final answer.